Technically speaking, technically speaking, I ain't talking vegan when I said that I've been eating, making money on the side, but I use it for the main. I'm speaking in code when I tech talk that financial freedom. Have a seat cause you gon' wanna sit up at my table, yeah. Plugged in that it, girl, IT with the cables, yeah. Network engineering is for you, it ain't no labels, yeah. Shaky with my passion, took a leap, it got me stable, yeah. Now I make 100K or better, paper couldn't fit a stapler, and I spend it on my passion cause I'm capable. Technically speaking, now I'm really talking vegan when I said that I've been eating, I've been technically speaking. Technically speaking, China white. When I've been said I've been technically speaking, said I've been technically speaking, China white.
All right, so welcome back to another lesson with the CCNA prep course. All right, we are in section 3, which is IP connectivity. This is learning about the internet protocol. Oh, we have a storm. Anyway, the internet protocol. And this is basically learning about layer 3. Okay, so we learned about layer 1, which is the physical, the cables, all the connectors, the switch, the router. Then we talked about section 2, which is layer 2 and switching and how layer 2 technology works, which is really just MAC addressing. And now section 3 is all about IP addressing, right? This is where we actually start routing traffic over the internet. Okay, so just make sure you guys keep that notebook. Make sure you keep taking these handwritten notes because that is how you're going to retain this information. Okay, ensure that you are making flashcards. Physical flashcards are the best, but we do have Quizlet in case you want to have some digital flashcards and take some quizzes. I'm thinking about in this week, we can do a nice trivia in the Discord, maybe even over Zoom where we can have some fun, play some trivia questions to ensure that we're getting where this knowledge is sticking to us and win some cool prizes. So let's go ahead and get started here. Now we're in section 3, 25% of the exam, pretty big. And today we're going to talk about 3.1. We're going to talk about the routing table and how a router makes decisions when they are routing traffic. Okay, this is the bare bones, the basics of how routers operate and how traffic routes. All right, let's go ahead and get into this blog here. Now, I wrote this blog when I first started. It's still tried and true information. When it comes to the CCNA and comes to just understanding how traffic traverses through the network, period. All right, so let's just start with the concept of routing. Now, as you can see here in this diagram, we have some routers and we have some routes, as you can see, these networks. Now, routing is just the concept of transmitting packets through the network. A packet is what we call layer 3 data. So anytime you hear packet, think of layer 3, which you think of routing and IP addressing. Okay, so a packet that we talked about last week is encapsulated with a layer 2 frame, right? Inside that layer 2 frame is a packet, a layer 3 packet. Packets travel through the network using IP addressing. Okay, and this is done through layer 3 devices such as routers or layer 3 switches, because layer 3 switches can route IP traffic, but it cannot do everything a router can do. That's why we still have a router in place. And on my side of the field, voice network engineering, we call these things gateways, voice gateways. So you may see VG, voice gateway. Just means that it is a router that is capable of transmitting audio through ones and zeros. That's all that means, okay? Now, routing has 3 elements, okay? They have protocols, routing has algorithms, and routing has a database, okay? Now, the protocols is what we will configure. Protocols like OSPF or RIP or EIGRP, you'll hear these type of protocols that you'll see there down here as well. These are protocols, and a protocol is a set of rules. So these are things that we will configure onto the router to say, hey, router, I want you to route traffic in these type of rules, in this type of protocol. Okay, OSPF is open shortest path first. Kind of makes sense in the name, open shortest path first, right? So it's gonna route the calls based on the shortest path first. And then you have other routing protocols that I don't think it calls for this exam, but it's good to understand that there are protocols and what their acronyms are, like OSPF, RIP, EIGRP, and so forth. Okay. Then routing has an algorithm. An algorithm is determined how the packet will travel. We call that the metric. Okay, a metric. We'll get into more of a metric, but a metric is just in case that the router has the same path and the same protocol. What one will they use? Let's say there's the same route that is on the router twice, right? For different reasons. And how do the router choose it? It chooses the best best route based on the algorithm, aka the metric. Okay, we'll get into metric a little more. And then routing has a database, and we call that our forwarding decision. We call that administrative distance. And all of this database is on what we have a routing table, just like a MAC address table that a switch has to see the paths via the MAC addresses and the ports. The router has the same thing, but it's called a routing table. It's a table, it's a database of all the routes that the router knows about. Okay. And when a packet comes to the router to say, hey, I need you to route, I want to go XYZ, the router is going to look at his routing table and see where should I and how should I send this data, right? They're going to look at his database. How do I forward this? It's going to do it by a certain algorithm and protocols that we configure onto the router. Okay. Now, just going in, these are some types of protocols. Now, not sure if they took this off the CCNA or not, but it's still good information to understand as you go on into understanding how routing works and how data traverses through the network. So we have these sections, categories of protocols. We have what's called a distant vector. We have a link state, and then we have a hybrid. Okay. Now, distant vector protocols, they're usually protocols that because a router is connected to another router, its neighbor, they can share routes with each other. So they'll say, oh, well, I can kind of draw out or understand what's next based on my neighbor, because my neighbor has information that I can get information from and see, like, so who are you connected to? What route are you? What device? And it will help you kind of like, it will help the router route traffic better because they understand, they can talk to their neighbor. Okay. Link state protocol is more like the router doesn't send everything to the neighbor. It sends what you want it to. Like OSPF, you can configure it. We will configure it in the next lesson, but you can configure it and you can say, hey, I want you to learn these routes for this neighbor, or don't, learn these routes from this neighbor. Hybrid of both is EIGRP, which I believe is kind of phased out, but you possibly will see it. I've definitely saw it in my environments. So, and again, it's just both. It's for you to be able to have both a distant vector to where you can just advertise everything with the router and its surrounding neighbors, and then link state, where it kind of builds a link, builds a topology based on the neighbor. It doesn't, route everything or show everything. Because in some protocols, a router will say, hey, once a neighbor or neighboring router or neighbor device asks for information, they'll just give it all up to it, and then some protocols, they'll say, well, what do you want? Ask me for some information and I'll give it to you instead of just advertising. Okay. Another thing to understand is IGP and EGP. Okay. IGP is interior gateway protocol, right? So that's devices exchanging information within each other, within what we call an autonomous system. EGP, exterior gateway protocol. So one is interior, one is exterior. So exterior is when they exchange information between devices that are not in an autonomous area. Okay, let me scroll down here. So this is like an autonomous area. Okay, as you can see these devices. So you can think of autonomous area as an area to where a network administrator will basically manage that one network, right? How I was able to understand it or get it stuck in my head is EGP is what they call the internet's protocol, right? Because EGP, exterior gateway protocol, is where a routing protocol where they're linking two different networks together. So I have a network, you have a network, but if we want to talk to each other, we would utilize a protocol called EGP, exterior gateway protocol. Right here in the middle, we have BGP. BGP is border gateway protocol, which is another instance of the internet's protocol. So EGP is
will be number 1 is TSU Team Hub. This is where all our hub information is at. This is where you'll go first, and you can ask questions here, create you a nice card with your name on it, and let us know what you're here, what your goals is, so we can help you accomplish that. Okay? The second board you would come up to is how to get a 6-figure job. This is my exact path on how I was able to break into tech and get a 6-figure tech job. Even when you got that job, or let's just say you are at a comfortable job, it may not be 6 figures, maybe, 90K, 80K, something in that sort, and now you're looking into making 6 figures in your business. You can use this board as well, so we can help you get to that goal with getting 6 figures in your business, okay, by utilizing technology. And the third one here that everyone mostly is at is the CCNA or Net Plus exam notes. All right. These are all the exam notes here. And we have it in our boards that you see where it has start, and you see our network fundamentals, network.
Like I said, like a type like IGP. They're just they're not really protocols that you're going to configure, but they're like a category of protocols, right? You have protocols that are interior and you have protocols that are exterior. There's only one exterior protocol, which is BGP. That's why we call it the Internet's protocol, because it's how these different networks are able to talk to each other through this one protocol, BGP. BGP is very, very important if you go deep into wanting to become a network engineer, especially on the data side. BGP, like I said, it connects us to the internet. The internet is nothing but a whole bunch of local area networks put together. We're connecting, we're talking to each other. So that's one of the only protocols that you'll really use when it's time to talk outside of your network, which is BGP. Everything else is IGP, which is interior. That's your OSPF, your IGRP, your RIP, and some other protocols. Okay, so it's really important to understand the difference, IGP and EGP, because that will definitely be on your exam. Okay, understanding the autonomous system, which we'll go in next lesson to talk about OSPF, because that's where autonomous systems really come in handy at, when we're start learning. Even down here, as you can see, ASBR is an autonomous system boundary router, a router that participates in OSPF and another dynamic routing protocol. So like I said, we'll talk about that more. I don't want to get too deep in it, but just understand that autonomous system and autonomous system boundary router are different. Some people get them in the same. Some people think they mean the same thing, which is OSPF, and no. ASBR deals with OSPF, which is a routing protocol. AS, autonomous system, autonomous area, is just saying that, hey, this is its own network controlled by one or many administrators, right? If there's another network that another administrator has control over, then that is a different autonomous system, right? I hope that makes sense, guys. So let's just keep going down. We talked about distant vector and link state. I'll give you guys this PDF so you can kind of go through the different protocols, okay? Now, going into metric and administrative distance, this is how the router makes these decisions through metric and administrative distance. Metric, like I said, it's just well, what we call it is the measure of how the distance, how the router will use the best path based off the distance. And the distance is obviously the shortest and the fastest distance. This measurement is based off of the routing protocol. Okay, so OSPF, they use a metric with bandwidth and cost. So was the router trying to make decisions on how to route the traffic, and it has an OSPF protocol or OSPF paths, right? It'll say, okay, based off the bandwidth/cost, is this a good way for me to send the packet down, right? EIGRP right here uses K values. These K values are synonymous to which one is the best path. RIP is about hop count, and they have different with protocols. With each protocol, they have their different ways of how they calculate metric. The point of it is shortest path first, lowest value, right? Wherever I can get there quickly and I guess more cost saving. Because in OSPF, which we need to learn more of than IGRP and RIP, these are kind of like outdated protocols. Kind of won't see that much. RIP was the first routing protocol, then came ERG, then OSPF. OSPF is kind of like the standard, you can say, especially if you're on the data side, networking on the data side. So if anything, lowest cost, then they will, that's the best path the router will choose. Okay. If for instance, there's 2 OSPF routes, then whichever one is the lowest cost, the router will choose that route to send traffic. Okay. Because we're always, when we're thinking about data being sent through, we want the data to be sent as fast as possible, but doesn't cost the company as much, right? So the router will make these decisions. Now, the router already comes with intelligence, okay? So you can plug it up, ready to go. But to ensure that the router routes how you want it to, and in your environment and how you set up the infrastructure, you would configure these protocols like OSPF and EIGRP. Because without these protocols, the router will send it based off what it thinks, right? And yes, it has intelligence, but who says, I want you to do it that way? You know what I'm saying? You still have to tell the machine what to do to some degree. It will be smart, will learn on its own, but you still have to, tell it what to do. Administrative distance, same thing, is using a certain measurement to ensure that the data gets to where it needs to and cost effective. So just like metric, it's the lower the number. So what we can do is we can actually statically set administrative distance for one path to choose it over another, right? You see static. But there are other ones that deal with the protocols. For instance, OSPF is 110. EIGRP is 90. BGP is 20, and static is 1. So if we're talking about the lowest, clearly we can see here, well, OSPF will take it over RIP, but EIGRP will take it over OSPF. So just in case you have, for instance, different protocols, but the same path. So let's say we have an OSPF path going to the next router, but we also have an EIGRP path going to the next router. They're still going to the next router. They're just different protocols. Which one will it, how would the router know which one to choose? Well, the lowest protocol, okay? So think of metric as more like the same. If it has the same protocols, it will choose the lowest cost. If we're talking about OSPF, it will choose the lowest value. And then for administrative distance, think of it as if it has 2 different protocols, but the same path, how will it choose? Well, it will choose it based off the protocol with the least AD, the least number. It's always the lower number that wins the best path. if you can think of it like that, whether it's metric or administrative distance, as long as you know that it's always the lower number wins, the lower number is what the router will choose to send data through, then you're good to go. Okay. I guess for the CCNA, it's more of remembering, playing a game of memory. What is the administrative distance for OSPF? What is the administrative distance of BGP? Right. What if there was a route that the router learned and it had static, it had IGRP, and it had directly connected? Which route where the router chooses as the best path to send traffic? Again, it's just memorizing which one is the lowest. Directly connected is the lowest, So if you see that directly connected, it should be 0. I believe for the next exam, like the CCNP, the professional, because the CCNA is entry level, then they'll probably have you go a little bit more into administrative distance. Maybe even as you are working as a network engineer, you may learn a little bit more. But for this exam, is really just remembering the ADs with the protocol. Okay, so this is great with flashcards. OSPF on one side, what is the AD of it? On the other side, put 110. Right. I think that's best, honestly, because that's kind of what they'll quiz you on. Maybe even the acronyms, they will definitely quiz you on the acronyms as well. What does OSPF stand for? What does BGP stand for? Intermediate system to intermediate system, I haven't seen that on the exam as far as like what it stands for or what's the AD or metric of it. Honestly, I see a lot of OSPF, EIGRP, and BGP. RIP, you may see it because it was the first routing protocol that came out. So you may see that a lot, but as long as you understand that it's a routing protocol, and you understand, like, it's 120 AD and it goes off hop count, that's really honestly all you really need to know about it. So like I said, flashcards is going to be a really big game changer for this exam. Because as you start to do stuff, do the labs, as you start to work in it, then things come full circle. Okay. Why is my battery dead? Hold on, let me plug in my battery. Oh, I didn't have it plugged in. Okay, anyway, so let's continue going on. Let's talk about a routing table. So this what looks like a routing table. Like I said, it kind of looks just like the MAC address table on a switch, right? It just holds all the learned paths. And the same way on a router, it's called a routing table. It learns its path. It's this database. So anytime that a router needs to gets a packet and needs to route that packet, it looks at this table and say, what port and which route should I choose, right? Which network should I send it off? And excuse me. And for the exam, you really just need to know how to read a routing table. So we're just gonna go through some components. So starting off with the prefix. A prefix is just the network address, okay? And you see it, the slash notation, and that's the subject subnet mask. So remember I said anytime you see a slash and then a number, that's nothing but the subnet mask. The subnet mask tells you where the network is and where the hosts begin. So these will all be network addresses. Now, as you can see here, we have 172.16.0.0/16. Okay, so we already know that this is the network, which we will call the prefix. Okay, so if the router wanted to send data outside to this network, it can send it to 172.16, and then the 00 is arbitrary because those can be the host addresses. But 172.16 is the network that it's going to. Okay. Network mask, we said that already. /16 is right here. It's just letting you know where's the network begins And then after that, you have the host. Okay, that's how you can tell the host and the network. We kind of talked about that in subnetting. So that's how you know how to subnet is finding where the host address is and the usable and usable where the network address is and where the usable host address are. Okay. And again, it's all subnetting. And as long as you understand slash notation, the /16, you are good to go. They also have the next hop. The next hop is saying, you know, the next line right here, the router next in line. So as you can see, it'll say 209.156.200.226. You see that address? So it's saying this address to the next hop via next hop. Okay, how do you know this address? Because it's the next hop. What is the next hop? It's just the next router in line to get this data, the next router that's connected. Okay, because the router only knows the information of itself and what's connected to it. Outside of that, they don't know. They don't know that it's probably 10 routers connected or 3 routers connected. All they know is who am I connected? I know what the routes that I have, and I know the routes that I'm connected to. So if I'm connected to 2 routers, you know, then I know those 2 routes. Okay, if I'm only connected to one, if one router is connected to another router, they only know that one router. Even though there's probably 17, 20 routers next in line. They don't know that. They can only see what's next. Okay. Routing protocol code. So we talked about routing protocols like OSPF, EIGRP, RIP. Those come on the routing table as just the initial. Okay. So you will see an O that stands for OSPF. You will see an R that stands for RIP. Okay. You will see a C that stands for connected. That's directly connected. And you will see an L for local. You'll see, you know, E for, you know, so you'll see all the different protocols, how this router learned this route. How did this route get on this routing table? Did it come from OSP? Did it come from a routing protocol, OSPF? Is it directly connected, C? Is it local, L? Things in that such, right? So that's how you can tell when you're looking at a routing table. You can see, okay, so from like, let's see for this one, the R, RIP. So this is what the router learned this route from this protocol. And then this route 172.16.2, okay, /24. So we know the network prefix, and then we have via, and we have this address 209, which is the next hop, okay? Administrative distance, we kind of skipped over that right here, but that's the 120, okay? And then the slash and the number is going to be the metric. So in these brackets right here, so you got R, the routing protocol, RIP, then you learned this network address prefix 192.168, right? You got the /16, again, it's network mask is letting you know where the network is at. And then we have a administrative distance of 120. And then we have slash, which is the metric, which is 2, via the next hop, 209.165.200, you know, that's the next hop. It's telling you the time. I believe this time right here is what they call BPU packets. It's like hello messages. It's basically the connection between one router and another router sends each other what we call hello messages every so often to ensure that it's still alive, it's still a good connection, still an active connection. So I believe that's what that timer right here is for. And then serial 0/0/0, we all know what that is. That is a port, okay? So when you're reading a routing table, this is what they want you to know as far as the CCNA is involved. And even your job as a network engineer, they're gonna say, hey, can you take a look at the routing table for whatever troubleshooting whatever troubleshooting you're doing? You wanna know what it means when you say show IP route. Okay, well, I'm seeing that we have some routes, some protocols already configured, definitely R, so that's RIP. You will also know like, well, RIP is a pretty old routing protocol, so they're not up to date. And then you'll see the network that they have learned, this router has learned. And if you already know that it's RIP, you already know this is 120, which is the administrative distance. We already know that. And then it says via this IP address. So you're like, okay, maybe I need to see where this leads me, which is the next router. Maybe you need to get into it. Maybe this is where the packet is stopping or dropping, who knows? And then of course it's in the port. So you can go into the port, go into the interface and see what's going on. Is there something going on with this interface on why you cannot send or receive data through this line? I don't know, so many different things, but this is a good way to troubleshoot, is looking at the routing table. And then, gateway of last resort, we didn't say that. That's just saying that the router is sending out, let's say the router doesn't have any path. Let's say a packet came in, the router doesn't know where to send it. They'll use the gateway of last resort, which is right here, 0000, to say, hey, just send it out of the gateway. Hopefully it finds its way. That's basically what that means, that the router doesn't have a route for it. And instead of just dropping it, it will send it out this 000. Okay. We call that like a default route. So think of it like that, like a default route. Gateway of last resort is what they call it as well. But you may see it always, you may see it sometimes as a default route. So if you ever hear gateway of last resort or default route, just know that it's a network of 000. Okay. And here's another little diagram, kind of breaks it down a little more. As you can see, routing source, destination network, administrative distance, metric, via the next hop, 209, right? The timestamp. So yeah, it is the timestamp of the hello packets. And then the outgoing interface, the port that we already know. Okay. So it's really good to probably draw out this right here. I think this is a good diagram to just draw out to get yourself familiar and for it to stick in your head that it starts with the routing source. It starts with the, and then it goes in the network / subnet mask. It has the administrative distance, the metric, via the next hop, the timestamp, and the outgoing interface. So if you can kind of write it down like that, you'll probably remember it. This will definitely be on the exam. They will ask you, and they will probably have it something like this, like a picture, and say, what's the next hop? And then they'll put in 172, they'll put in serial 00, they'll put in something random, and then they'll put in this 209, this next hop. So it's good if you can understand how to read this line, because that's an easy question, right? We don't want to get easy questions wrong. So yeah, and that's a lot of the questions. You may get like 2 or 3 like that, you know? So like I said, it's a game of memory. So I think you should write this down and try to memorize it in some type of form. Okay, let's go on. So the routing source, like I said, this is learned behavior through the routing source because we configured a routing protocol, or it can be something like automatic to where the router has a directly connected network or connected path to its port. So it'll be automatic. And then statically, every time you see static, remember that is something that we have set. So anytime you see statically or static in any form when it comes to computer networking, that means that we have went into the router, went into the switch, went into whatever device, and statically put this here. The router did not learn it on its own, okay? And through routing protocols, dynamically, it's gonna learn different routes through the protocol. That's why we set protocols, because the router has intelligence, but the router doesn't know what we want it to know, what we want it to do. So we have to set these protocols to say, hey, I want you to learn this network that is, connected to you, or, whatever the case may be. We want to set certain rules that the router will behave in a way that we set it, but also in a way to where it's like dynamic. It learns as it's I guess, getting more traffic. It'll learn like, okay, even though you told me to do this, I'm learning, almost like machine learning. Like I'm learning and I'm growing and I'm doing things on my own, right? That's kind of like a machine learning type of thing. But the router, like I said, it has intelligence. It will route dynamically, but you do have to put a routing protocol to make it what you want. Okay. Static and dynamic. This is good to know. Like I said, static is what we set. Dynamic is what the learned behavior of the router. Okay. Static, we kind of talked about it, directly connected. And then dynamic, ADs that are higher than one. Okay. What is a one AD? Or, which protocol has a AD of one? That would be static. Anything under than static is directly connected. So it's good to understand it in that, those little tidbits, because I know for sure that's going to be on the exam, right? Tomorrow, well, we kind of already did it, but tomorrow we'll do some more, which is configure some IPv4 and IPv6 static routes. Basically, static route is saying, hey, send traffic from here to there, from there to here. Imagine a infrastructure with 70 routers. You're not going to want to do static route on 70 routers and 16 different routes. That's insane. That's why we have routing protocols. But it's good to know how to configure static routes, because there may be an instance where you have to have traffic directly go to a source. You have to make it go to this source for internal reasons. It could be all type of reasons. Maybe the CEO or something was like, hey, I only want this going here. Whatever the case may be, you will have to add static routes. I've added some a bunch of times. So this is definitely something you'll use not only on the exam, but in real life. Okay. And this looks like another little diagram of just dynamic routing. See, like I said, EGP, exterior gateway protocol, is the only BGP is the only EGP, right? EGP is a category, right? Exterior gateway protocols. So what's an exterior gateway protocol? Protocols that talk between autonomous systems, between different networks. The only protocol that is BGP, okay? Border gateway protocol. Kind of all sounds exterior gateway, right? Border gateway, like if you kind of look at the word, it kind of makes sense, right? Interior gateway, right? Inside, interior gateway protocol. So if exterior only has one, which is BGP, then everything else is IGP.